All right, so let's look a little more detail about the location of electrons, because the location that the electrons are in is very important to how elements behave. So we're going to look at the location of electrons for every element based on three main ideas: the Aufbau principle, Hund's rule, and the Pauli exclusion principle. And this is going to allow you to draw an electron orbital diagram and the electron configuration for all elements. So we'll define what all those terms mean. So there's something known as the rule of eights, and in the old days it was believed that other than the first two elements, hydrogen and helium, all elements had 8 electrons in their outermost orbitals. And this rule of thumb will serve some purposes, as we're going to see in a future lesson, but it is more complicated than that. So the first orbital or place where electrons are going to be found is what's called the s orbital, and S stands for sphere. And basically the s orbital is a sphere that surrounds the nucleus of the atom, and within that sphere, within that zone, you're going to find 2 electrons. So all s orbitals hold 2 electrons, and these electrons can find their way around any place along that sphere. As the atoms get larger and larger, you add more and more s orbitals, and so the volume gets larger, the space that they're located at. So as you take a look at this image here, you'll notice what we call the 1s, or the first sphere, this first s orbital, and it's going to contain 2 electrons. When you add more electrons after that, we are going to add another sphere to it that's a little further away. Remember, electrons repel each other, so if you try to stick too many electrons in that s orbital, they'll start to repel each other, and it's going to kick one of them out or others out further from the nucleus. And so since the 1s can only hold 2 electrons, a new sphere forms a little further from the nucleus, and we call that the 2s, or the second sphere. And it also can contain 2 electrons. So if you try to stick a third electron in that, it's going to get bumped out further away. The repulsion of the electrons are going to push it further away, and so we add a third sphere, or the 3s. Then we add a 4th sphere, and then a 5th, and then a 6th, and then a 7th. So there's just one sphere being stacked on top of another, and each electron that we add is basically being added further and further away from the nucleus. So there's another type of orbital out there called the p orbitals, and the p orbitals sit inside of that sphere. And the p orbitals can exist in 3 dimensions. So the p orbitals are these lobed areas, and they also, like the s orbitals, can hold 2 electrons. So imagine in this 2p orbital, you've got an electron over here, and you've got an electron over here, and they're going to be jumping back and forth between the 2, but they can only hold 2. Now that orbital happens to be on the z-axis, or the up and down axis. But you can also go in other directions in space. So you can add one that's going out on the y-axis, or the x-axis. So you can hold 2 electrons right there, and you can go in the other axis. So remember, these are 3 dimensions. 3 dimensions have 3 axes, and so you can have 3 different types of p orbitals. So you can have up and down, left and right, in and out. And these 3 sets of p orbitals can end up holding a total of 6 electrons. In the end, if we look at them all, they all kind of look like this. And so just imagine 1 electron in each one of these. So we're talking about a total of 6 electrons in the p orbitals. Then if you want to know where so those are the 2p orbitals, 2py, 2px, 2pz. And then the sphere that sits as the 2s sits outside of that, and it also can hold 2 electrons. And now we have a total of 8. So that's where that rule of 8s comes from. You can have a 2s, and then you can have 3 different 2p's, and that adds up to 8. Now if you try to add another electron to that, that's going to have to form even further out, and then that would be our 3s. And then we would start adding more p's. So there'd be like a p here, and there'd be a p here. You can forgive me for my poor drawing, and a p here, and now we've just added 8 more. So as we add more energy levels, as we add more electrons and they get bumped out further and further from the nucleus, we start stacking these orbitals on top of each other. They're going to have the same shape and the same orientation, but they're going to be further away. And so, for instance, as you look at this diagram, we've got our 2p z up and down right here, but when we bump it out further, the 3p comes out further out from the nucleus. So there's the 3p top and bottom. We also can do it on this axis here. So here's your 2p and then here's your 3p. And we can do it further out in the z-axis, that in and out axis. You can't see it, but the 2p is inside in this area right over here, and then we've got our further out one. One way we can visualize where these electrons are located and actually map that is to shoot X-rays at atoms and see where the X-rays are either reflected or pass through the atom. And the X-rays are going to identify the location of these electron probabilities, or where the electrons are located. And so as we look at this diagram here, we're going to see, okay, so this right here shows where the 1s orbital is. And then here, there's the 1s located in the middle, and then here's your 2s located out here. Same thing with our 3s, so there's the 1s, the 2s, and then here's that sphere, that's the 3s. As we look at the 2p, we've got one of the lobes of the 2p, that up and down lobe right here, and then that's the same up and down lobe right there, only with the 3p, it's the same shape, only bigger and further out for the 3p. As we look at the 4s, it's 1, 2, 3, 4. So as we add more electrons, the atoms get larger and larger as we add more shells further and further from the nucleus. And the 4p, well, there's a 2p, a 3p, and a 4p. By the way, there's no 1p. The 1s is too small to hold a p. So the first set of p orbitals happens only in the 2s level, or that second shell, that second distance from the nucleus. So here's kind of a way of visualizing it. So we've got our s and our p's located here. And then here's our 2s. So if we go back, here's our 1s located here. We've got our p orbitals going along the x-axis, the y-axis, and the z-axis, and then all of them are contained by that 2s sphere that's out here. Okay, so when we're talking about energy levels, we're talking about essentially the distance from the nucleus, and that also gives us an indication of how much energy these electrons have to have. And so we're going to start with a 1s, and the 1s is going to have 2 electrons. When we have 3 electrons, it's going to be up here in the 2s, and then it's going to add the second one, so now that we've got 4 electrons. And now the 2p can hold up to 6, so it's 1, 2, 3, 4, 5, 6, and so now we have 10 electrons. Then we jump to the 3s and we add 2 more. Then we jump to the 3p, 1, 2, 3, 4, 5, 6, and so forth. So we just start working our way up, or getting further and further from the nucleus. And just a little note here, you'll notice that the 4s is lower than the 3d. We haven't talked about what d orbitals are. We'll get to that later on. But after 3p, we jump to 4s.